Okay, I will go ahead and get started. People are still joining. That's not a biggie. Like to thank you all for joining. This is Computer Science 201, Section 60 at UMBC for the fall 2020 semester. Need to get the right file open here. Have that in just a second. In the meantime, what I'm going to do is a quick introduction. So,
here are today's contestants. An orchid special from Hollywood, California, Ethan Talbert. A computer security engineer from Ellicott City, Maryland, Al Arsenault. And our returning champion, a software engineer from Salt Lake City, Utah, Ken Jennings, whose 7-day cash winnings total $231,000.
okay. So one of those three people will be your instructor this semester. Spoiler alert, it will not be the guy who won the game. Let me get the appropriate file to start this lecture. Here we go. That's the one we want. So that is a little bit about me. A little bit more. You can see here. The video I just showed you is a link. It's on my YouTube channel, which is where the course lecture notes are posted. I am an adjunct here at UMBC. My full-time job, currently I work for a company called the MITRE Corporation, which is a nonprofit that does government contracting. I've been teaching at UMBC this time for 3 semesters. I've taught 201 both last fall and last spring. Prior to that, I taught for a total of 8 years at UMBC. So this is the total of the 19th semester I've been teaching at UMBC. I've taught various programming, Java, networking, cybersecurity, and other classes. And as I mentioned, I taught 201 last fall and last spring. In addition, I was a visiting professor at the United States Air Force Academy and taught cadets. And while I was in grad school, I was a graduate teaching assistant at Purdue in West Lafayette, Indiana. I taught calc and probability and statistics. On this slide, you will see my email and my cell phone numbers. You are welcome to contact me at any time. Just a heads up, I have a please do not use this email address. That's actually my son's email address. He has the same name as me. He is also Alfred William Arsenault. He goes by Will. And he has a good laugh when people send him email asking questions of me. So please, if you look up Alfred Arsenault to the UMBC directory, you'll probably get directed to him. Don't. arsenault@umbc.edu is me. That is the easiest way to contact me outside of class if you need to. A little bit more about me. My first degree was from Southeastern Louisiana University a long time ago in physics. I got a bachelor's degree in physics and said, what can you do with this? Well, in Louisiana, they will be happy to teach you to be a petroleum engineer, and you can spend your life working in the Gulf of Mexico on offshore drilling rigs, which did not sound a lot of fun to me. So therefore, I finished up my degree in computer science and went to grad school. I got a master's in comp science statistics from Purdue a long time ago. And a few years ago, I got completely insane and bored, and I attended a mostly online program at the University of California, Berkeley, and picked up another master's, this one in data science, with a focus on machine learning and artificial intelligence. I am married. I have 4 kids, all of whom are now out of college. My oldest, Beth, went to Hood College, which is in Frederick, started in journalism and now works in marketing. My son, Will, as I mentioned, got his comp sci degree from UMBC and still has that email address. He just finished his master's degree at Johns Hopkins, and he works as a government contractor developing software here in the area. My daughter Kate is a College Park grad with a master's from George Washington, and she does a lot of big data analytics and online programming or online course development in the area. My youngest, Mary, is a 2018 graduate of UMBC. She got degrees from UMBC in psychology and media communication studies. And she currently works for Google in the Washington, D.C. area. And of course, I have two dogs who probably will be barking throughout the course as we go through this. But that's a little bit about me. And one more, I work in cybersecurity. I've been in that field a long time, doing all kinds of area operating systems, networks. And as I mentioned a few years ago, I got particularly interested in big data analytics and machine learning. My wife and I are into competitive ballroom dancing, which is the current hobby. I used to coach youth sports. If you're from Howard County or familiar with the area, I used to run the HCYP girls softball program. I also have a private pilot's license and jumped out of planes as well, although I haven't done either of those in a long time. That's me. Now, let's talk about the course. There's a lot of material to cover today and also in Wednesday's lecture notes. So we'll talk about this. Now, 201 is the first course in the CMSC sequence. For those who are majoring in comp sci, it's followed by 202, which is a second semester programming course in a different language. And if you're a comp sci major, you have to get a B or better in class or it doesn't count. You don't have to do that, obviously, although in the first semester it was pretty successful, even though even with everything taken into account. Important note here, do not assume any programming experience in this class. I always get a couple of students who want to pull me aside and go, look, I've never programmed a computer before. Am I going to be okay? Yeah, you're going to be okay. Both in the fall, in the majors classes, and in the spring, some of the best students I had have never programmed before. That's fine. It's kind of easier because what it means is that we have bad habits that we have to break. So this is all, it's not a big deal. If you do have programming experience, that's great. I'll warn you, we try to break those bad habits gently. You may be a little frustrated sometimes because you know how to solve this problem already. We'll teach you how to solve it properly. Okay. This is a computer science course. It's not just a programming course. Okay. What that means is we teach you how to solve a problem. We teach you how to implement your solution by writing a program in Python, but we teach you the proper way to solve the problem. Proper design, enforcing all the proper concepts, and then we get into how you can apply programming to your field of study. It always sounds negative. I don't mean to put down those programs that teach you to code, coding for this, coding for that, how to code. That's fine. But you'll hear me use the term slinging code. Slinging code means we've just got a problem and we just throw something together and gosh, it seems to give us a right answer to our problem. Okay, that's it. It doesn't get into the right way to solve the problem. So what we're going to do in this course is teach you the right way to solve the problem. So it's not just I can code a solution to this, as I can solve any problem like this that comes along. That's the focus of this course, and that's why it's a computer science class, not a programming class. There are all kinds of different languages that you will see. C++, Java, JavaScript, R, Python. If you're in big data analytics, you see a lot of R. Google likes to use a language called Go, or Golang for short. You will see those a lot too. But Python is a very good general purpose language. It's widely used. If you're in cybersecurity like me, it's very, very common. A lot of big tools use it. because it's flexible and helps you solve your problem. If you're into machine learning or artificial intelligence, you'll see Python a lot. A nice thing about it, and we'll get through this in the course, is that it's open source, it's freely available, you don't have to pay for it. In a minute, we'll download it, and you so you can have it on your own computer. If you don't have it, it's good to go. There's a whole lot of code out there freely available. It's a nice language to have. It is not fast. As computer languages go, if you need to code something that screams, that absolutely processes the most data possible, that runs as fast, you can't wait a microsecond. Okay, you don't have a microsecond to wait. C++ is thousands of times faster than Python, but Python's pretty darn good. But these days, speed is not really the big part of computer programming. Why you would use a language? Throw more hardware at it. Go to the cloud. Get more instances in the cloud. So there's a lot of it that speed is not important. If you are in an environment where speed is absolutely critical, you'll use C++ or something like that. Python is generally fast enough, and it's work. It works. Okay, end of the class, you'll be able to use this approach. You'll be able to break down complex problems. You'll be able to write and debug programs in Python. You're going to become very comfortable with the Linux environment at UMBC, and we'll get you into that in just a minute. And you'll be able to develop Python programs on your own computer. Okay. Now, I want to skip through a lot of the rest of the introductory material. You can read the things I have here. They're available online, and we'll talk about them. What I want to do is start you off in Python. I've given you a link to this site. This is called GitHub. GitHub is another site where people can share code and materials. So I've put all of the important information on this site. Now, I do use Blackboard some, but I've got to be honest. I apologize if anybody's a Blackboard fan. I don't like Blackboard. I find it awkward. I find it difficult to use. And so as a result, I put a lot of things on GitHub. Now, you will find if you go to this site right now, 4 different repositories. Not all of them are used, but some of them have material. If you look at Fall 2020 lecture notes, you will see 2 files. They're PDFs. You can download them and look at them. Don't worry about the README. That's just it says it has this sentence. It says it contains the lecture notes. The slide set I was just working through is right here in the intro to CompSci 201 material. And it'll pop up and it looks like this, what you've seen. So you have all that. You have the references. It has the links to all of the academic integrity rules. It has the links to all of the where to get help, to student disability services. It has the links to all the material. Don't want to downplay that. That is important. It's all there. If you have any questions, let me know. But what I want to start doing is moving in to getting you programming. And the first homework is actually out there. We'll get to that in a minute. It's due next Wednesday, the 9th. But I want to talk about this particular set of lecture notes and how we're doing this. Okay. I originally scheduled this to be Wednesday's lecture. We probably will not finish it today. I want to work through this for you, and we're going to do some things together with coding. I want to start with using GL. In this class, you will submit all of your homework assignments on a Linux server owned by the CompSci department and actually the College of Engineering, whose address is gl.umbc.edu. And that is how you will do your homework. And so homework 0, which is out there now, which is worth 10 points, it's on that GitHub site that I just mentioned. It gives you practice at dealing with GL. Now, if you have a Mac, I use a Macintosh. I try to have a Windows machine available at all times. But when I'm speaking to you right now, I'm speaking to you from my Macintosh. If you have a Mac, it works like this. You bring up a terminal window. And let me share this. Okay. Here's my terminal. Okay. Now, let's make sure, is everybody seeing my terminal window right now? You can just type in the chat, yes, no. Or you can speak. Go ahead.
Yes.
Got it? Cool. Thank you. Okay, this is what a Mac terminal looks like. We're going to talk about Windows in just a minute, but I want to demonstrate this first. If you have a Mac, you type the command SSH. SSH is for secure shell. That address I gave you, gl.umbc.edu. This lets me remotely log in. Whoops, there's one mistake in there. Apologize for that. I'm going to use my account, Arsenal at gl.umbc.edu. Now it will ask me for my password. Now, Linux is different than other systems that you might have seen. I will type my password. You'll notice nothing showed. It didn't give me asterisks or dots or whatever. It did not echo your password. Okay, Linux just works that way. So if you're trying this yourself and you're logging into GL and you're not seeing anything when you're typing your password, don't worry, it's taking it. Go ahead and check. Go ahead and make sure. So again, if you're on a Mac, you SSH, you log in, it's your email address at gl.umbc.edu. It is the same password. The password you use to log in for email is the same password you use here. This is now a Linux environment. So I am now using the Linux operating system. This is the server. Everything will be done on this system. What I'm looking at right now is called a command script or a shell. Okay. And this particular one is called the Born Again shell. We'll get to that in a minute, or bash. So if somebody says type a bash command, that just says, what's the command you use on GL? What's the command you use right now? To look at the files, I'm going to use the ls or list command. List shows me what files I have on this computer. Okay. CS201 is actually the directory I used in the fall. Bin is for binaries. Demo.py is a Python program I ran. Hailstone.py is a Python program, and so on. I have projects and things in here. This will look like yours. You will have, when you log on, type ls, and you will see what files you have now. Now, you're going to create a directory, and let's make a new one. It's just the make dir command, make directory, CS201 fall 2020. And I now see that I have this CS201 fall 2020 directory, and that's how I can do things. So this is how to get onto GL and how to do things. And we'll talk about homework 1 and homework 0 in a bit. It will walk you through this. Now, I understand most people use Windows. If you use Windows, you need to install a program on your, let me go back to sharing Chrome. Okay, if you're going to use Windows, you need to install a program called Putty. P-U-T-T-Y. So if you go to putty, P-U-T-T-Y.org, and this is on the slide, it gives you a place to download the program. Given that you're going to be on Windows, this will be the file you want to click on and install. And then you'll have it running on your Windows box. And then when you're running putty, this is just a 3-minute video, or a 1.5-minute video, actually.
Here's our first attempt to log into GL using putty. There's a couple of settings we need to set up with first, and that is inside putty. This window is going to show up. We have a host name, which is going to be gl.umbc.edu, and the port is going to be 22, but also the connection type is SSH. Now, once you put all that in, we can put save, make sure there's a title somewhere up here, hit save, and it'll be all done for you the next time you want to log in as well. I'm going to go ahead and hit open. And if all the settings are correct, you should have this screen pop up as your login. First, your login is exactly the same as what you would have for your email. So go ahead and put in your username first and then your password. As you can see, I just put in my username. I am now putting in my password. And here we go. If we have made it this far, then we've been successful. We're in the remote system or the remote computer being GL. None of this is on your computer. Anything that we do, save material, write material, all that is done on the remote computer. So I'm going to do ls here, and I'll go over more of some of the other commands in Linux later, but at least wanted you to see what ls does, and that basically lists what's inside the directories, which again we will go over later. But that is your first successful interaction using putty.
Okay. So let me get out of that window. Hang on just a second.
Okay, so.
Okay. Back to the slides. So that is very quickly how to get onto GL. Now we have to learn how to actually run programs. We'll get to that in just a second, but that's what you're going to do. That's how you're going to do your homework. That's how you're going to submit it. It's a Linux system. As I said, it uses the bash shell. A shell is Unix vernacular for a command line interpreter. It's a command line system. It's not a GUI system. There's no Windows. There's no anything else. You're learning this the old-fashioned way, typing commands at lines. There's a whole bunch of different shells out there. There's the Z shell. If you have a Mac, the Mac prefers Z shell now. One of the original ones was called the C shell. And then a guy by the name of Stephen Bourne was a programmer who wrote something called the Bourne shell. And then later on, some other people decided to improve Bourne's shell, and they called it the Bourne Again shell, or Bash for short. Bash is fairly standard. It has a list of commands that you can type, and it tells you, how to interact with a Linux system. Again, you're going to interact. It's all commands. There's no GUIs. Emacs is an editor. We'll talk about that in a little bit, to create files and edit them. The command you type to run Python programs is Python 3, and we'll get to that in a minute. Everything is executing on that server. The only thing happening on your system, on your laptop, is the input and output through your Mac terminal or your Windows PuTTY window. Okay. And there's another video I'm not going to show, but it shows some other things. This was the 3-minute video I was mentioning that talks about how this is happening. Okay. The point of all this is when you're doing your homework, everything is done the old-fashioned way. Okay. You're creating files in a text editor. You're running them at the command line. You've got to debug. Okay. But there's got to be, this is more on Python. Skip that. there's got to be a better way to do this. Okay. I mean, we understand that to grade your homework, to give you help with how you're doing, we have to be able to have everything done on the same system. You do this in GL because there's 9 or 10 of you enrolled in this class. Overall, there's almost 600 students enrolled in CompSci 201 this semester, which is pretty much standard. Every semester is around 600 students. We have to have you running all the programs on the same environment so we can grade them using our software. That's why you do it this way. But let's be real. Most of you want to do most of your work on your system. You want to do it on your Windows box or on your Mac and only do the stuff on GL when you're ready to submit. We understand. Here's how you do it. You can and should have a Python implementation on your computer. If you don't already, you can go to a website called python.org. And again, all of these slides are available for you. You don't have to follow me in real time. There's always a couple students who try to follow me in real time and point out questions, ask questions, point out errors. That's great. I'm happy with that. Lots of discussion is good. Okay, if you go to python.org, this is where you can download a Python interpreter. You go to downloads. Now, python.org has figured out that I have a Mac. And so by default, it's offering me the most current version is Python 3.8.5 for Mac. Okay, if I said, no, I want the Windows version, that's not a problem. I'll click here, Windows. If you go to python.org with a Windows box, it's going to offer you by default the Windows version. You want some version of Python that's in 3.8, the 3.8 family, and you want to download it and install it. It's a fairly straight process. You install the software on your system just like you would anything else you downloaded from the web, and then you have it on your system. I'm not going to download it because I just did it this morning to make sure it works. You'll have the version downloaded and installed. Now, to use it, by default, just like we did on GL, here's a terminal. Let me log off of GL. You log off by the exit command, and now I am back on my Mac. This means that I'm on my Mac. Now, I've downloaded and installed Python. And so just make sure, there's lots of errors in teaching this class, which is good. It teaches you how to deal with them. To run a program in Python, you just, let's see where I am in here. I'm in my home directory on my Mac. I have a whole bunch of files here. I'm going to type Python 3. Python 3 on a Mac starts me in what's called a Python console, and now I can run Python programs. If you are on a Mac, here's a warning. Mac OS up to and including Catalina comes with an old version of Python installed. You will have Python 2.7 already on your Mac. If you type Python at the command line instead of Python 3, you will be running the old version of Python, and that will cause a problem. So always make sure you're typing Python 3, and that lets you run a program. If you have a Windows box, this is going to be very similar. You install Python, you download and install, just like I just showed you. Now you have Python on your Windows box, and now you simply start up a command shell. You start up a command prompt on Windows, and you're going to type Python 3. And now you're running in what's called a Python console. Okay. A Python console means this. Python is executing each line of code you type as soon as you type it. As soon as you hit enter, Python executes that line of code. This is called a Python console. Now, let's go back to the slides before I do this. That's running it from a terminal or a command shell. Your first Python program, as I said, you're all going to have, you're going to be Python experts by the end of this class at 5:15, because this is, fairly straightforward. Anytime you learn a new language, you start by running a program that prints out "Hello World" just to prove that this thing works. So this is what we're going to do. Okay, I go back to my terminal and I type the command print, parentheses, in quotes, "Hello World." And this is a complete and valid Python program. I told the Python interpreter to print out "Hello World." It printed out "Hello World." And I have now run a Python program. Well, on the slide, I don't have exactly that. I have some different things. So let's follow exactly what I've got on the slide. Anything that starts with a pound sign or a hash or a sharp, depending on what your major is. If you're a music major, this is a sharp. If you've spent some time in England, this is a hash, or if you like hashtags, or a pound sign. This is what's called a comment. Now, a comment is something that the interpreter is going to ignore. So Python is going to ignore everything after this pound sign. But for me, this is useful. See, Python did not execute that because it just ignored it because it's a comment. Okay, anything that starts with a pound sign. I'm just doing things that a human would understand. Now I'm going to write what I've done before. And you can see that these lines together are perfectly valid Python program that causes Python to write "Hello World" on the screen. So here we have Python running on my Mac in a command line program in a Mac terminal. I started by saying Python 3. It opened this up. It opened up what's called a Python console. It gave me prompts. I printed my Python. I typed in my Python program. It ran. And now this works the same Mac or Windows. By the way, this is in Python. I'm going to leave. Okay. So, comment. This is our first Python program. "Hello World" on the screen. These means nothing to the Python interpreter. This is just notes for a human to understand what we're doing. This is your Python command. This is the entire Python program. You can now run it easily. Now, that doesn't save anything. This is all gone. As soon as I'm done, this code is gone. It doesn't exist anywhere. I can't recover this. This stuff I did right here in my Mac terminal, I can't recover it. Okay. So I could, and we'll get into how to do that. I could save everything to a file and then execute it all at once. And I want to get to a different topic before we go on there, because we'll skip that. If you're into C++, this is a different way to do the same thing. This is what I want to talk about. There has to be an easier way to run any computer program, in particular Python programs. There has to be an easier way than what we've just done, doing it at a command line. And indeed, there is. There's a way to run code and test it when you want to see how something works. There's a way to load files and run them directly. There's all kinds of ways to do that, okay? And that easier way is called an integrated development environment, or IDE. So when you hear IDE in computer science, IDE stands for integrated development environment. It contains all the tools you need in one package: an editor, a Python interpreter, a way to debug things, a file manager. Now, for the most part, this semester, I'm going to write and run Python code as part of lecture to clarify what we're doing, to explain things, to illustrate it, to test things. How does that work? Why does that work? What happens when I do this? Okay. When I do that in this class, I will occasionally run it on gl.umbc.edu. I will occasionally run it in the Mac terminal if I'm in a Mac, or on a Windows command shell if I'm on a Windows box, but not a lot. I'm mostly going to use an IDE because it's just easier to show and fix things. Okay. The IDE that we're going to use, what I'm going to do for the next 5 minutes or so, is not a mandatory part of this class. But if you're going to use your own laptop to do the programming assignments, to do the programs, to do the tests, this is a good thing to have. Now, there's a bunch of different IDEs out there. The one I'm going to use in this class is called PyCharm. Okay. The TAs, like I said, since PyCharm is not a mandatory part of this class, the TAs are not responsible for teaching it. They don't give you a lot of time debugging PyCharm. They'll help your Python. The TAs are paid to teach you Python, to help you with your Python programs. They really won't get into PyCharm. But this is a pretty intuitive version. And so what you can do, whether you got Windows, Mac, Linux, whatever, you can go to this location, this link I've put in the slides, and download what's called the community or free edition of PyCharm. Okay. The latest is version 2020.2, which is fine. That's a good one. Again, the community, if you look over here in this column, the professional edition, these are ones you're going to have to pay for. You're going to have to shell out a couple of $100 for that. Please do not. Please do not pay for the professional edition of PyCharm yet. It is, if you're going to get a job programming, if you're going to get a job coding, we can talk about it. For this class, you want the community edition, and the latest is 2020.2.1. Now, you can pick the version you want. If you have a Linux box here, if you have a Windows box here, if you have a Mac OS box here. You do not need the one with the Anaconda plugin. We'll talk later in the semester about what Anaconda is. Everything in Python has a snake motif. Somebody thought it cool. I'm a computer scientist. I'm allowed to say this. Computer scientists are geeks. We think things are funny that really aren't. One of the things that's humorous is everything in Python, because Python is a snake, has a snake motif. So part of an extension is Anaconda. It's another snake. Cool. You don't need that. Pick the one that you need, Windows or Mac. You can download it. You can install it on your system. When you have PyCharm loaded and installed, once this is up and running, I will share that with you. Okay. This is taking a little bit to load. Shouldn't be a big problem. All right. There we go. Okay. All right. When you get PyCharm running, it will look something like this. Okay, you've got your standard toolbar up top. You've got your directory structure for whatever files you want. This window is where you can have your code, your file, whatever. This is your editor. Okay, so this top right window is your editor where you can create Python programs and run them as a whole. This bottom left is a Python console. This is what I just showed you on my Mac. This is the equivalent. So here you can type lines of Python code and they will be executed immediately. Print hello world. Okay, and just like before, the Python console immediately executes that program, executes that line of code and runs it. Okay, now up here, as I said, this is your edit window. And let's get a new file here. I'm going to delete all that junk. I'm going to create a file. This file contains a Python program. Print hello world. Okay, now I can come up here and I can simply execute that and it will run the program. It'll give me the response and it'll tell me it finished. Okay, so this is PyCharm. So what we want to do right now, or what we want to do before the next class, is it would be good for you to do is, if you're interested in that, go ahead and download and install it, and we'll work on some more examples on Wednesday. This is not directly related to Homework Zero. Homework Zero has you write the program in on GL. Okay, so we've done the hello world on the screen. A few terms you need to know. Comment. A comment is preceded by this pound sign or this hashtag. It's a it's text you write to explain to a human what is going on in your program. Okay, if the human needs to understand, then you write a comment. Okay, and we'll talk through this as we go through the semester, how you write comments and what you need to do. Literal. And what do I have? What do I have next as the slides? Hang on. Here we go. I've got explanations of these here. I did have time to put. I didn't know if I didn't remember if I had time to put the slides in. Sorry. Comments. Notes you write for yourself and for other humans to explain what it is you're trying to do. Okay. You start it with a pound sign or hashtag. Anything after that on a line is a comment. It's ignored by Python. This is a comment. Now, you note down here, I don't have to start a comment in the beginning. I don't have to start a comment at the beginning of the line. Here is an example of where print hello world is my Python command, and Python will interpret it. Once I hit this pound sign, once I hit this hashtag, that becomes a comment and Python ignores it. So I can put comments later on in the line. I don't have to put this on a separate line. All you need to know about a comment right now in a Python program is it's something you write for yourself, for other humans, and you don't, it's not something the compiler or the Python interpreter does anything with. When you write a program to be useful, you have a variable. Okay. A variable is a symbolic name associated with a value. There's a location in memory. And this is when I really wish I was alive in front of you, because this is where I get out my markers and draw things on boards. It makes it a little bit easier to understand, I think. If you think about memory, memory is just your computer's memory is just a long array of boxes that can hold things of a certain length. Okay, so there's one location in memory, and it can hold hello world. And another one location in memory can hold the number 6. These are just locations in the memory of your computer. This one has hello world. This has 6. They can hold different types, different amounts of data. This is just where it's stored. Okay. Well, a variable is just a name for this. In order for Python to understand what's going on, something has to have a name so it can locate it. Okay. So you say, this is S. I'm going to tell Python, call this thing S, this location in memory S, and Python will say, got it. This location in memory, I don't care where it is. You know, I'm sitting here looking at a computer with gigabytes of RAM, literally, right? I got gigabytes of, I don't care where in those gigabytes of RAM this one location that has hello world is. I'm not going to remember a numerical address. I'm going to tell Python, I want it called S. Python will say S. S is a variable. It is this name I will associate with this location in memory, wherever it is that has hello world. Or T. T is the name of this location in memory that has the variable, that has the value 6. Okay? So this is a variable name. This is a variable name. When I talk about a variable in a Python program, that is just a symbolic name associated with a value. The name, S is the variable, T is the variable. Hello world, this is location in memory, is a value. Okay. When you use a variable in Python, the Python interpreter grabs a location in memory, don't care how or why, and associates the variable's name with that location. Then any values assigned to that variable are stored and read from. Okay. So, I'm sorry, somebody asked me a question. I apologize. Okay. So what I want to do is hopefully illustrate this a little bit. Undo. Okay. Your computer has all this memory. As I said, gigabytes of RAM. And each location in memory is just sitting there waiting for something to be put there. So along come you with your Python program, and you're going to say, I need a location in memory and I want to assign the value 6 to it. And what Python does is it says, aha, here is an empty location in memory. I shall call this location in memory T, because you said you need a location in memory. So I shall call this location in memory T. And into this location in memory, I will put the value 6. That is how Python works. That's how all computer languages work. Declare a variable. A variable is a place to store a value. Python says, I want a location in memory. I'll put in the value. We've got it. Okay, so that when I say variable, I just mean one of those, and we'll cover that in detail. In Python, variable names must start with a letter or an underscore. You cannot start a variable name with a digit. If you start it with a digit, it's not a variable. There are some other examples in here. Getting back to the terms. Literals. A literal is an explicit value that is to be taken exactly as it's written in the program. It is not a variable name. It is not something that changes. When I said print hello world, that hello world was a literal. I told Python, I want you to print exactly this. Print hello world and nothing else. Now, it's a string literal to do foreshadowing. There are other literals that are not strings, that are integers or real numbers or something else. Okay? Literals. You also have constants. Constants we'll get to later on. I'll come back to this Wednesday. I'm trying to make sure I cover some things so you get homework 0 done. Okay. Let me stop this because I'm being too confusing. I want to do some more things before I get into this. Okay. Just making sure I'm sorry, just reading the chat messages now, making sure I'm okay. Yeah, Blackboard Collab does have a whiteboard feature. I may force myself to use it. I'm not a fan of it, but I may force myself to. We'll get there. What I want to do now is show you what homework 0 is and walk through it. So if we go back to my GitHub site, you will see fall 2020 assignments. And you will see that homework 0 is out there. Now, homework 0 requires you first to log in to gl.umbc.edu. Okay? Once you've done that, you will be logged on. You'll see a prompt that looks like this, Linux 3, number 1, or something similar. You will create on GL, or you will create a CMSC homework, CMSC 201 directory. That works like this. I'm here on my Mac. Making sure I'm sharing the terminal. Yep, okay, we're good. I'm sharing my terminal. There we go. Okay. And let's wipe the rest of this stuff out. Okay. I will log in again. Okay. The command is the one I've already showed you, mkdir. Okay, mkdir says make directory, says create this directory that's going to be called, in your case, CMSC 201. So let me make sure I don't already have one. I do not. So let's make a directory called CMSC 201. And now I can see that I have this new directory. Okay. Then homework 0 says change into that directory. And then we want directories inside there called labs and homeworks. So inside, we're going to change into wait a minute, where am I? Where am I currently? I'm in my home directory. Okay, now I'm in the directory CMSC 201. There's nothing in it. So now I will create a directory called labs. And I will create a directory called homeworks. Okay. So once you've done those, you can do homework 0, change into your homeworks directory, make there again, create a new directory called homework 0 and change directory into it. PWD just tells you which directory you're in right now. Okay. Now create a file. Simplest way is to use the touch command. Remember, we're making you do this the old-fashioned ugly way. Touching a file, it just creates it with no content. So if I say, let's change into homeworks. Let's create a directory, homework 0. And now we see that this directory, this file exists. Okay. So Emacs is an editor. You will have to create this string. This is what's called a comment block, a header comment. And looking through the rest of homework 0, the key is how you hand in homework. Okay, submitting your homework 0.py file is how you submit it. Type this command, it will tell you okay, and then you have handed in your homework. Okay. In CompSci 201, all homework is submitted, all your programming projects are submitted this way on gl.umbc.edu by this command. You are permitted to submit multiple times. If you submit multiple times, only the last is graded. If you, so please, okay, homeworks are usually due at midnight on their given due date, 11:59 p.m. And GL has a pretty accurate clock. GL will stop accepting homeworks at midnight. So please, there's always somebody every semester who says, I had it all, it was grand, it was glorious, it was great, and I went to submit it, and then my internet connection went down. And by the time my internet connection came back up, it was 12:02 and it would not accept it. Then we have all kinds of problems. So please, if you're doing a homework, if you're doing a lab, submit early, submit often. When you've got it 90% done, submit it. When you got 90% done, submit it. That way, guaranteed, you're going to get 90% of the credit. Okay. You can submit it again later when you've got it perfect, and then it will, you'll get full credit for it, everything. But basically, homework 0 asks you to work through the things that I've shown you, which is to actually write a program on GL and submit it for credit. And then after homework 0 is done, there's you'll have that part down and we won't have to worry about it. Okay. I apologize. I should have told you this at the beginning. Those of you who had discussion section scheduled this morning already discovered there is no discussion this week. Okay. Discussion sections, the 11 o'clock, I think on Monday and Wednesday, are not being held this week. If you have the Wednesday one, don't worry about it. Normally, the teaching assistant will walk you through this, but that's not happening this week. This is due next Wednesday. Now, for those of you who have lab on Monday, if you're in section 61, I will talk to Jeffrey, who is the TA covering that class, about getting you something, because there is no class on Labor Day. Next Monday is Labor Day. There is no class. There's no lecture next Monday. So I want you to make sure you do have one lab before this is due, which is next Wednesday, the 9th. Let me talk to Jeffrey and I'll let you know. For this week, there is no lab whatsoever. For next week, there is, except for Monday, which is Labor Day. I will talk to Jeffrey and we'll get that worked out. But you should be able to do homework 0. As I said, you may. If you're on Windows, you will have to download PuTTY and install it. If you're on a Mac, it's just a straight terminal and SSH into GL, and then you're ready to go. Now, I've got about 12 minutes left. I'm going to cover the rest of this Python programming on Wednesday. I apologize. It seems like I'm rushing through. I actually did practice this, but there's a lot of stuff to cover to get you going. Okay. Homework 0 is on GitHub. I will put homework 0 on Blackboard tonight. If you are having trouble getting to GitHub or whatever, I will put homework 0 on Blackboard. Don't worry about that. And I will put all the announcements and everything on Blackboard. That'll be said. There's one thing I put in the lecture notes, I think, is tools. We are going to inundate you with tools in this class. Sorry, but that's what happens when we have to go online, and it'll be a benefit to you. I mentioned GitHub. GitHub is a tool I will use for class notes, homework assignments, and sample exams. For lectures, I will use, for now, WebEx. I record all these lectures, and I post the recordings. Usually WebEx takes a couple hours before it makes available, but all the recordings will be on my class YouTube channel. That Jeopardy game that I showed you the introduction of at the beginning, the whole game is on the that YouTube channel. If you get bored one time, it's all there. It's about 20 minutes long. And as I said, Ken Jennings won because he's the greatest of all time, and I'm not, but it was fun. I may change later on to YouTube live streaming. The problem with YouTube live streaming to me is it's harder to get feedback from you in real time. It's harder to get you to ask questions in real time. So for now, I'm using WebEx. The 201 majors classes, Professor Hamilton's, Professor Wilson's, they use YouTube live streaming. I'm going to do WebEx for now, for the foreseeable future. As I said, YouTube live streaming problem, I don't like. It doesn't let you ask questions of me very easily. But for labs, we're using a tool called Discord. Discord started out as a tool for video gamers and has since become quite popular. You should have all gotten in your email an invitation to join Discord. If you haven't, let me know and we'll figure out why you haven't. You should have gotten an invitation to join Discord. If you've used it already, great, no problem. If you have not, Discord will look, when you log in, it will look something like this. Let me share this now. Okay. When you get onto Discord, it will look something like this. It's a whole bunch of different channels. Yours will look slightly different than mine because I have a couple of instructor sections that you don't have access to, but that's okay. The main thing is you will have on the left side, if you, by the way, if you have more than one Discord server, if you're already a video gamer, if you're already on Discord, if you're on Discord for some other class, this is just adding to it. This is the Discord server for this class. It's called CMSC 201 Fall 2020. That's the one for previous classes. This is direct messages, things like that. You will see a list of channels called course rooms. They have discussions in them. All 500 and almost 600 of you have accounts on Discord, so some of these may get busy. Don't try to keep up with everything. There's a general channel for general discussions, and you can see a number of your fellow classmates have already been going at this, been logging on and discussing things. There's a course room or a channel for tech support. If you have problems with GL, if you have problems with something, you can ask in the tech support channel and get help. If you're into wasting time, there's a channel for memes. There's a channel for pets. People are posting pet pictures. I created a channel specifically for this group for Section 60 called Non-Majors Discussions. It's available. Students from other sections can see this, but I figured since there's only a few of us, and later on in the semester, you're going to have different homeworks and different tests and different other things from the other students. Then, I wanted a channel that somebody will go, I don't understand. Why is this a homework question? That's not a homework. Yes, it is for us, not them. So that's a place you can look at. There is also, if you scroll down, a room for every lab section. So those of you in the Monday lab section, this is Lab 61 is for your room. Jeff Martin is your TA. He's posted a welcome notice for you. You should make sure you check out that room. Again, talk to him about how he's going to handle the Labor Day holiday. He will make sure he gets you a lecture. We'll work out the details. The reason we pick Discord is that it has a voice channel. You can actually go into a voice channel and talk person to person with your TA, with other students. There is one of those for each section. So this is the 61. Since that was normally would have been today, Jeff has already created that. The Wednesday section 62, this is your channel. It has not been created. It will be before Wednesday. These are your rooms. And you'll notice there's a room for every discussion section. Stay in your own, please. Don't go heckling people in other labs. As I said, you'll see the other rooms. This is Discord. This is how you'll be using labs, and this is also for office hours. If you need help during office hours, you can go to any 201 TA during office hours. I will do some office hours myself. The other professors do office hours as well. We'll make sure somebody's there. If you need help, if you have a question during office hours, go into what's called the waiting room. And in the waiting room, you can put in requests. And TAs will be there. And when they respond to your requests in the waiting room, you will be taken into a private text and voice channel with the TA. That's where you go for help. So Discord is important because it's how we're doing labs, and it's also how we're doing office hours with the TAs. So take a look. Try to make sure you get on it before Wednesday. And if you have any questions, we'll get it. We'll make sure we cover it on Wednesday. Okay, now I want to go back to Chrome. So let's minimize Discord. Sorry. And let's go back to Chrome. So you've seen GitHub. You've seen Discord just now. As of right now, I will not put up a Slack channel for this class. I used a Slack channel for my class in the spring that was in addition to Discord. Some people were more comfortable with Slack than Discord because you might have used it at a job you've been an intern for or something. Right now, I'm going to try to handle all of those discussions on that we did on Slack last time on Discord. So if we need it, I will put up a Slack channel for this class for discussions. Right now, we're going to try to do it on Discord. The Python tool, I showed you how to download it and install it. An IDE, PyCharm, again, that's optional. If you want to download and install it, that's a tool you'll use as well. gl.umbc.edu is the Linux server. You will run your code and submit your projects. What a number of students like to do is write and debug and run their code on PyCharm on their laptop and then upload it to GL when it's done. That's fine. That's a good thing to do. You don't have to do it. A lot of people choose to do it that way, but it has to be submitted on GL. If you are actually editing your programs on GL, you will use Emacs. Emacs is a text editor. It's not a word processor. It's not a Word of Pages or something like that. It is a plain old ugly text editor developed in, I think, 1972 or something like that. And you know, it's what we give you. And then I mentioned Bash. It stands for Born Again Shell. It's just a command line processor for telling GL what to do. I bring that up because people go, well, what's a Bash command? I don't understand. What's Bash? Bash is just the commands you're typing on gl.umbc.edu. Those are more tools. I had hoped to be able to go around and talk to everybody briefly. What I would like you to do is send me an email message between now and Wednesday, telling me your name, whether you're a freshman, sophomore, junior, senior, telling me what your major and minor is, and tell me one thing you like to do or what's your hobby, what's the thing you're doing, so I know a little bit about you, okay? And then we'll try to fit that in on Wednesday. Like I said, I understand this seems like a disjointed lecture. I apologize if you think that way. But I wanted to both talk to you about this course and what it's going to be and how it's going to be and why it's different from the major sections, as well as give you the materials necessary so that if you want to start Homework Zero now, you can. You can get on Discord, you can get on GL, you can create directories, you know a little bit about Bash. Again, Homework Zero is not due till next Wednesday, September 9th at midnight. So we've got 2 more lectures since there's no class next Monday. You've got 2 more lectures. If you have any questions, if you have anything between now and then, we'll get you up and running with it. So, bottom line, that's the intro. Everything I've talked about plus more is on GitHub. Wednesday, we will go over this programming in Python bit more slowly, in more detail, and hopefully have a better explanation of everything for it. There is no lecture next Monday, the 7th. It's Labor Day. There is no lab if you're in the Wednesday 62 section this week. There will be no lab, but please go to Discord and make sure you can connect. Make sure you can talk to your TA. If you can't, let me know and we'll get that covered. And other than that, I will turn the fire hose off, and you can sort of recover until Wednesday. Because, as I said, I know I hit you with a lot. There's a lot to cover in this class. I'm glad you're in the class. I hope you all have fun. I hope it's enjoyable. I understand online education was not what you signed up for when you enrolled at UMBC, but I think we can do this pretty well, and I think you'll come out of this learning how to program Python pretty well and how to be a computer scientist. If you have any questions, I'll be happy to answer them. Other than that, as I said, I gave you a link to my YouTube channel. I will, once WebEx finishes processing this recording, I will post the recording to the YouTube channel. That will always be there. And other than that, send me the email, and I will see you on Wednesday at 4. So any questions, feel free to ask. Other than that, you can log off.
Professor. Hello. Professor.
Yes.